Hi folks, welcome back to 1.1 part 2. And so in this part, we're going to take a look at multiple representations of functions and relations. And in particular, we're going to take a look at mapping diagrams, tables, graphs, and equations. And all four of these ways are just going to be different ways to show the same thing, the same relation or the same function. All right, so for example 5, let me just give you a big picture of what we're going to do here. So I'm going to give us a mapping function, the thing with the two blobs from part 1 where we connect the two sets with arrows. We're going to use that to complete a table, and then we're going to use that to draw a graph. All right, and once we've done these 3 representations, we're going to go ahead and answer the first set of questions here. And this first set of questions will help us determine whether our relation is just a relation or whether it's a function. Okay. And then we'll take a look at this second piece or the second set of questions, and these will help us determine whether we have a special type of function or not. Okay. So let's get started with our mapping diagram. And so in our mapping diagram, in the domain or the first set, I'm going to give us 5 numbers, -2, -1, 0, 1, and 2. And in the second set, or the range, or the output, I'm also going to give us a set of 5 numbers, -7, -4, -1, 2, and 5. Now, in order to finish our mapping diagram, we need to have arrows telling us which object from the first set gets paired with which object from the second set. And it turns out that -2 will pair with 5, -1 will pair with 2, 0 will pair with -1, 1 will pair with -4, and 2 will pair with -7. Okay. And taking that information from our mapping diagram, we can go ahead and fill in our table. So I'm going to have -2 in for the x, and the y that goes with it is the 5. Right? So we have -2 to 5, and so we write that as an ordered pair. If we keep going down our list, we'll get -1 goes to 2, 0 goes to -1, 1 goes to -4, and 2 goes to -7. All right. So now we've turned our mapping diagram into a table representation, right? 2 different ways of showing the same information. The last representation we're going to look at right now, before we look at the questions, is the picture. Okay. So I'm going to take these 5 coordinate points and I'm going to plot them on this graph. Now, for some of us, maybe it's been a while since we've graphed. And so let's go ahead and remind ourselves of a few things. In particular, this horizontal axis is our x-axis, and we have positive x values to the right and negative x values to the left. And then our vertical axis here is our y-axis, and we have positive y values at the top and negative y values at the bottom. All right. And so when we're plotting these, we're going to grab a coordinate point, -2, 5. And that means that we're going to start from the origin. We're going to go 2 to the right and 5 units up. That's going to put our first point at right here, -2, 5. If we go for the next coordinate point, that's -1, 2, we go over to the right one and or to the left one and up 2, and we get our second coordinate point. We're going to do the same thing for the other 3 points. So 0, -1, 1, -4, and 2, -7. We're going to connect these 5 points with a line. All right, so now we have our three representations, and now we're going to go ahead and answer these three questions. Now, the reason why I wrote three separate questions is because each representation has almost a different way of looking at it to help us find out whether or not it's a function, okay? Is it just a relation, or is it what we call a function? And so let's take a look at our mapping diagram first. And we had talked about this earlier in part 1, but in our mapping diagram, what we're really looking for is, does any one x value go to more than one y value? All right, does any x value go to more than one y value? And so if you remember from earlier, we had somewhere like the -2 would go to 5, but it will also go to another number, and that was not a function. So in this case, I noticed that every value in our domain only goes to one value in our range. So the answer is no. We don't have any y or x values go to more than one y value. Now, the way we ask ourselves that in our table is we say, does any x value show up more than one time? Right? If I had -2 goes to 5 and -2 goes to -7, I would have had to have -2, comma 5, and then another -2, comma -7 somewhere else, right? And so when I look down my list, all of the x values, they only show up one time. So does any x value show up more than one time? No, my friends, it does not. Now, what's the big deal about an x value showing up more than one time? Well, turns out on our graph, that is equivalent to this idea of what we call the vertical line test, okay? In particular, if you draw a vertical line anywhere in your graph, will it cross more than one time? Okay, and so let me zoom in on this graph a little bit here. A vertical line might look something like this, a line that goes straight up and down. This one only crosses the function, whoa, blew the surprise there, the function one time. I could draw a different vertical line. It only crosses the function one time. And no matter where I draw these vertical lines, each line is only going to cross the function one time. All right, so if I draw a vertical line, will it cross the graph more than one time? The answer is no. And if all three of these first set of questions are no, that means that we have a function, okay? So let me make a note for us. We'll squeeze this up here. This is a function. All right. Now, in fact, some of us might be looking at this either from our graph or from the coordinates and realizing that we actually could figure out what the equation is here. And it turns out that if we take a look at our graph, we find our y-intercept of -1. We also see that the slope is going down by 3 over 1, down by 3 over 1, down by 3 over 1. So we actually have a slope of -3. If we put those pieces of information together, we can write in our function notation that the equation is f of x equals -3x minus 1. Okay, so this would be our equation that also matches our mapping, our table, and our graph. All right. Now that we know there's a function, let's take a look at the second set of questions, because sometimes we have a special kind of function called a one-to-one function, okay? So these three questions down here will help us determine whether we have a one-to-one function or not. Let's start with our graph, okay? This time it says, if I draw a horizontal line, will it cross the graph more than once? So I'm not drawing vertical lines, but I'm doing the same idea where I'm sort of imagining a bunch of horizontal lines and seeing, does each one ever cross more than one time? And I can see from this picture that each of these lines, no matter where I put it, is only going to cross one time. All right. So if I draw a horizontal line, will it ever cross the graph more than once? No, it will not. That's a good sign. All right. The equivalent way of looking at that on our table is, does any y value show up more than one time? Right? And if I'm looking at my, if I'm looking at my y values, 5, 2, -1, -4, -7, they each only happen one time. So I can go ahead and say, no, no y value shows up more than one time. Now, the last way we can look at that in our mapping diagram is we can say, does any one y value come from more than one x value? All right. In other words, maybe 0 goes to -1, but maybe also 1 goes to -1, something like that, right? Does any one y value come from more than one x value, right? So these two going to that -1 would be a yes, but if we look at our diagram, every y value only comes from one x value, so our answer is no. All right, now last time, when we were asking the questions of up here with our vertical line test, things like that, all of the answers were no. That meant that it was a function, right? Now, if we get all no's down here, what does that mean? That means that what we have is our function is 1, 2, 1. All right, our function is something that we call, it's a one-to-one function. All right, and all it means to be a one-to-one function is that every x value has a y value and every y value has an x value. We don't double dip on those. They don't share any y values here, okay? Every x value has its own y value. All right, let me get this all on one screen real quick for us so we can kind of see what we've done. Our multiple representations here, right? We've seen that we can draw the pictures, we can fill in a table, we can draw a mapping diagram, and we can analyze these to determine whether something's a function or not, and whether our function is one-to-one. All right. So I've included 2 more examples like this. If you like, this is a good time to pause the video. You can go ahead and work on those 2, try them on your own, and then come back. And if you'd rather follow along, then we're going to move on to example 6 right now. All right. So same idea here for number 6. We're going to go ahead, and this time I'm actually going to give you the table first. All right, we're going to use our table to draw a mapping diagram and our graph. Then we're going to say, is this a function? And if it is a function, we're going to say, is it a one-to-one function? Okay, so let's get started with our table. Suppose we had x values 0, 1, 2, 3, and 4. And then the y values that went with those were 2, 3, 4, 3, 2. Okay. So let's take these and go ahead and plot them on our graph first. All right. So I've got 0, 2, 1, 3, 2, 4, 3, 3, and 4, 2. All right. And this might be a shape that's familiar to us. If we connect them, we get this V shape. We get a V shape. And the name of this kind of function, we'll just jot it in here for ourselves, is absolute value. All right, we're going to be learning a lot of different kinds of functions. Absolute value will be one of those. That'll be really nice to know. Okay, so far we've got our table, we've got our graph. Now let's go back and make our mapping diagram. And so in our mapping diagram, we need our domain values. We've got 0, 1, 2, 3, and 4. And then in our second bubble, we need to have our numbers that we have for the y value. I notice that I have 2, 3, 4, and then I have 3 and 2 again, but I don't need to write the numbers again. I only write the numbers one time, right? So I'm only going to write a 2, a 3, and a 4. I'm not going to write 2, 3, 4, 3, 2. Okay. And then I need to draw the arrows, right? This is not a complete mapping diagram. I need to draw the arrows to make sure that I've got the right pairs, the right coordinate pairs, right? So 0 goes to 2, 1 goes to 3, 2 goes to 4. All right. But now we have 3 goes to 3. So I have to draw 3 going to 3. And then lastly, I have 4 going all the way back up to 2. All right. So it's okay for the arrows to crisscross, right? But now I think it makes our analyzing question maybe a little bit more interesting than they were last time. Okay. So let's go through and determine in this picture and table and graph, do we have a function or not? Okay. And so we're going to ask ourselves in 3 different ways. Does any one x value go to more than one y value? Well, every x value only has one arrow going from it, right? So like 0 goes to 2, 1 goes to 3, 2 goes to 4. Those don't go anywhere else. And then 3 goes to 3, 4 goes to 2. So no, x values do not go to more than one y value. All right, in our table, does any x value show up more than one time? All right, a quick glance here. We have 5 different numbers. So no, we do not have any x values that show up more than one time. Now, so far, this is good. Our answers agree, which is important, okay? And this is telling us so far that what we have is not just a relation, but it is also a function. All right, last test, that vertical line test when we have a picture. If we draw vertical lines through, will it only cross one time? That is true. So no, it does not cross more than one time. And let's see, I drew that up at the top last time. What we have is a function. Right? It is a function. And then an equation that we have for this, all right? And we'll learn how to write these equations later on, but the equation for this particular function is as follows. F of x equals negative absolute value of x minus 2, and then plus 4, okay? And in fact, we are going to spend quite a bit of time this whole summer looking at like, how do we know what this negative sign in front does? How do we know what this minus 2 does? And how do we know what something like a plus 4 at the end does? Okay. All right. So far we have an equation, a relation that is a function, but now we need to say, is it a special kind of function? Is it a one-to-one function? Okay. So let's start with our mapping diagram, all right? The question is, does any one y value come from more than one x value? So let's look at how many arrows are going into the y values. Now 4 only has one arrow going into it, but 3 actually comes from 3 and 1. And 2 actually comes from 4 and 0. All right. So does any one y value come from more than one x value? Yes. Actually, we have a few examples of that. Now, the way we look on the table, if we say, does any y value show up more than one time? Well, I see 3 on here twice. I see 2 on here twice. So yes, we do have some y values that show up more than one time. And the last test, the one we use on our pictures, if you draw a horizontal line, will it ever cross the graph more than one time? Bingo. Right here, I've got a line crossing twice. So, yes. All right. So we have a function. It's an absolute value function. However, this function is not one-to-one. All right. Because of these double y values, we do not have a one-to-one function. So it is a function, but because we answered yes to this function is not one-to-one. Right? It is not one-to-one. So let's get all of this on one screen so we can take a overall look at it, but similar ideas, example 7, multiple representations, really trying to see how do we know from each representation what's happening. All right, let's take a look at one more example together. That'll be example 7, and that'll be the end of this part 2. All right, so let's start this time. I'm going to give you a picture, and then we're going to use our graph to go ahead and fill in our table and fill in our mapping diagram. All right, so a lot of practice in going between the different representations. And I'll give you the equation here, just like I did for the other ones, knowing that we're going to spend a lot of time this summer session looking at the equations, but we want to make sure that we can see the connection between the representations first here, okay? All right, so let's start with our graph. All right, our graph looks something like this. 1 point here, 1 point here, 1 point here, and 1 point here. All right, now if I gave you more points, then what we would find is that we actually have a circle. Okay, so it is not a diamond or a rhombus. Okay, turns out if I gave you more points, it would be a circle. So let's see how the drawing is feeling today. Ah. Ha, that is so bad it thought it wasn't even a circle. Let me try that again. Ah, better. There we go. All right, so we've got a circle here. Let's list out the points that we had in our table, okay? And so I'm going to start over here. This point, I went 3 over, and it didn't go up or down any. So that's 3, 0. And then in no particular reason, I'm just going to go in this direction as we list the points, okay? So 3, 0. This one would be 0, 3. This one is -3, 0. And this one is 0, -3. All right, so -3, 0, 0, -3. And we only have 4 quote unquote nice points here. So I'm just going to scratch out this last one. We don't need that. We've only got 4 points on this. All right, so we've got our diagram, we've got our table, and now we're going to go ahead and fill in our mapping diagram. red blob and a green blob. Okay. So what numbers should I put in my domain? Well, I've got a 3, a 0, a -3, and another 0. But since I already said 0, I don't need to put the 0 again, okay? And then normally we write the numbers from smallest to biggest. So in other words, I'm not going to write 3, 0, -3, but I'm going to write -3, 0, 3, smallest to biggest, okay? Now in our range, what do we have? 0, 3, 0, -3. So same thing again, I don't need to double write the 0. I already have one, but I should write it in order from smallest to largest. So just like I had for the domain, I'm going to have -3, 0, and 3. Okay. Now let's see what goes where. Let's see. -3 goes to 0. So -3 goes to 0. Right? 0 goes to 3 and -3. 0 goes to -3 and 3. Now, I bet some of us can already say, whoa, Judy, let's stop right there. We actually already know that we don't have a function, okay? Because this single x value goes to 2 different y values. And maybe some of us had already seen that when we were looking at the picture. If we drew a vertical line, it's going to cross more than one time, right? But let's go ahead and finish our mapping diagram here. So -3 goes to 0, and 3 also goes to 0. So 3 goes to 0, right? So if we were to answer this first set of questions, right? If you draw a vertical line, will it cross the graph more than one time? Yes, it will. Does any x value show up more than one time? Yes, we get the 0 more than one time. And finally, does any one x value go to more than one y value? Yes, 0 goes to 2 different places. Since all of these are a yes, this is not a function. Okay? It is a relation, but it's not a function. And if it's not a function, then we don't need to worry about if it's one-to-one, because it's not even a function. Okay? All right. The last thing I want to leave you with here is, what was the equation for this particular shape, this circle? Okay. And we will learn about this later this summer, but I just wanted to plant some seeds for right now. Okay. It turns out that we can write the equation of a circle like this: x squared plus y squared equals 3 squared. And this 3 squared comes from the radius being 3, and then we square it. Okay. Now let's do a little bit of algebra here, because what I want to do is make sure we know how to isolate different letters. Okay. So for example, here, I am going to try and get y all by itself. All right. So let me go ahead and copy this. We're going to bring this down here. So we give ourselves a little bit more space. All right. So if we were to isolate y here, all right, the first thing we could do is subtract x squared from both sides. I'm going to subtract x squared, and I'm going to get y squared equals 3 squared minus x squared. Okay. Now we're going to try and get not y squared, but y. So we're going to take the square root of both sides. So I get y equals, now 2 super important things here. Number 1, when we take a square root, we end up with the positive and the negative version. Okay, we need to make sure we've got a plus or minus. square root of 3 squared minus x squared. All right. I am actually going to stop here and I'm going to put a box around this. And some of us are probably sitting at home or wherever we are choosing to do our learning environment and saying, why isn't she doing this? Right? Just take the square root of every single piece. Right? This, my folks, is very illegal. Right? This is very, very illegal. And I want to take the time to show you why that is right now. Okay? So let's do off in the side. We're going to just plug in some numbers. Because I think sometimes numbers are so useful to helping us figure out whether things are true or not. Okay? So I want us to pick a number for x. We're going to plug it in and see what number we get for y. And then we're going to take that same x value, we're going to plug it in here and see if we can get the same y value, right? Because if it's not illegal, then we should get the same number. Plain and simple. All right, so let's do this. Let x equal 1. Okay, let x equal 1. Then y equals plus or minus the square root. Let's see, 3 squared is 9, minus 1 squared is 1. So then y would be plus or minus square root of 8. Okay, and if we plugged in 1 into a calculator and did this on a calculator, we would get plus or minus square root of 8. Okay, so that is what we think is our answer. But let's talk about why we can't just take the square root here. Well, if I say y equals plus or minus 3 minus 1, I just get plus or minus 2. And the square root of 8 is not 2. All right, so just by plugging in numbers, we can see these two are not the same, which makes this very illegal option not an option. Okay. So I need us to be really careful about that as we move through the summer. When we have a square root something and it's like a plus or a minus in between here, we can't just take the square root of both sides like that. Okay, we have to leave it inside the square root. All right, we're going to stop here for part 2. Come back and join us for the last section, which is part 3 of this section of notes. See you later.